Hello, 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 everybody, and welcome back. We're looking at question 20 on the 2008 grade 7 level Gauss contest. Question 20 says the product of three different positive integers is 72. What is the smallest possible sum of these integers? Alright, so we have some pretty small numbers here. And the first thing I'm thinking is three different positive integers, and we want small sums. We should try and get these numbers to be pretty small. That's at least the thinking. We could try something like, I don't know, 1. 1 might be one of the products. One might be one of the factors. That certainly wouldn't be too bad. But, you know, what could we really do there? Is there a reason to think that 1 should necessarily be one of the answers? I'm not entirely sure. But let's think about 72 itself. Well, let's get a little space and think about 72 itself. So there's lots of ways to write 72 as a factor of three things. You know, we could have 1 times 2 times 36. Do we really want to write out all the possibilities? You know, 1 times 8 times 9. Lots of things there. You could do other things like 3 times 8, although that's not product of different integers. But you could have 3 and 6 and 4, I guess. There's lots of them. So what should we do? How should we approach this question? Well, on the surface of it, if we play around with another number, let's say something like 18. How can I write 18? And let's not go for 3 factors, let's go for 2. 18 can be written in lots of ways. Okay? And you'll notice that, you know, you can do 1 times 18, but the sum there is going to be 19. You can do 2 times 9, the sum there is going to be 11. You do 3 times 6, and the sum there is going to be 9. It seems as the numbers get closer together, the sum gets smaller. Okay? And this is not unique to just splitting it up into 2 factors. This happens with 3 and 4. If you want the sum as small as possible, but you want the product to be some fixed constant, you often want to get the numbers to be as close as possible. Okay? And that's sort of a principle that we can pick up. Closer numbers equal smaller sum. And, you know, I know this is the grade 7 contest. I don't want to get too deep into things. I don't want to scare anyone off. But there is a reason for this. Okay? There is something called the arithmetic mean, geometric mean. If I take any 2 numbers, call them x and y, the average of those 2 is always greater than or equal to the square root of their product. Now, if the product here is fixed, that gives me a nice lower bound for as small as this sum could possibly be. Okay? And you get the smallest thing when these 2 numbers are equal. Now, that's not going to work for our purposes because we don't want equal numbers, but it gives us a nice idea. And in fact, there's an arithmetic mean for 3 numbers as well. And if you haven't seen this before, that's okay. It's something to look into maybe in the future. It doesn't come up. I mean, it's not required for a contest like this. We can always just sort of mess around. And if you're going to just mess around, pick some examples, try and notice patterns, and don't worry about just keep a running tally. So 1, 2, 36 is 39. 1, 8, 19 is 18. So 18 is as good as I can get. 3, 6, and 4. Well, now that's 13. Can I really beat 13? And you can just keep trying. Eventually, you'll exhaust all possibilities. And, I mean, if I look here, 13 is pretty good. The answer is either 13 or 12. Okay? I've got something smaller than 14, 15, and 17. So just experimenting, we can start to narrow things down. But there is, you know, sort of exact math ways to go about doing this, or at least a reasoning to think closer numbers really is a smaller sum. Okay? Closer numbers, the closer together the x, y, and z are, the closer, the smaller this value can become. Okay? So, you know, this is it's not just an idle observation, it's something that can really happen. So we ask ourselves, Well, we need close numbers. 3, 4, and 6. Can we really get any closer than that? No. You can try and mess around with it. You can try and do something like 2 and 3, but that's going to shift the other number further out. Frankly, the only thing that's closer would be something like 4, 5, and 6, where they're really, that's as close as we can get. Where they're all sort of cheek to cheek, just 4, then 5, then 6. But that doesn't give me a product of 72. Only 3, 4, and 6 does. None of the other ones will. So 13 is almost certainly the answer, based on the principle that closer numbers give me a smaller sum. But there isn't an exact sort of, you do this, you do this, you do this, and you're done. Okay? There isn't something for a question like this, nor should there be. I mean, it's grade 7 math. It's question 20. It's a little hard. You don't want to list them all out. And eventually you have to say to yourself, well, I'm sort of noticing this pattern. I really don't think I can do better than 13. And that's what I'm saying. I don't think I can do better than 13. My reasoning is the closer the numbers seem to get together in the product, the smaller the sum is. 3, 4, and 6 gives me 72. And, I mean, there's really just a tiny little gap there between the 4 and the 6. That's about as good as I could ever ask. Now, if I think the numbers should be close together, what could I do to sort of give me a general idea, a general ballpark? If the numbers are close together, and if I've got 3 of them, if they're all close together, then, A is very similar to B is very similar to C. If they're close together, they're basically the same number. So the product, which is 72, should be sort of close to just A multiplied by itself 3 times. Okay? So these 3 numbers, A, B, and C, should be kind of close to the cube root of 72. And that's where we can start using our calculator. You got a cube root button, or at least I hope you do. And we can get the cube root of 72 is about 4.1. So these numbers should be really close to 4. Well, we've got numbers here really close to 4. And 3 is as close to 4 as you can get without actually being 4. So that further strengthens our resolve that the answer should be A, 13. Okay, so that finishes up question 20. It's not exactly a satisfying answer, because, again, I wasn't able to do this, 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 and I'm done. Okay? There isn't really a way to do that. But, we got really close, we used our reasoning skills, and that's still math. Logic and reasoning are still math, even if it's not calculations and algebra. Okay? That finishes off part B. I will see you guys in the next video as we start off part C with question number 21. Until then, take care.